Any viewers?
No. Okay. Everybody who is paying attention to reversing. We are going to start by going over the one from yesterday. So the challenge problem from yesterday. I'm having a little difficulty accessing my keyboard though because somebody keeps bumping into me.
Oh no, I'm not.
Okay. Here's the dump from yesterday from this program that I gave y'all to reverse. And so I was giving you a hint at the end. There's this stuff right here at the beginning that gets instantiated on the top of the stack, and that's just like local variables that are getting set. And then I also was pointing out that there's a comparison and then a jump right here. And so if we go ahead and run this in GDB. Oh yeah, sorry. Okay, so if we do B, or let's look at this as main, then we could go to this comparison right here, and we can set a breakpoint at it. And so, like yesterday, you can use the star and then main, and then that is an offset 217. So now if we run it, we can enter whatever we want. So like nothing of importance, but then we can look at what's inside of these registers before the comparison happens. So if we just do, or we don't even need to do that. We could probably just look up in here. So we got EDX and EAX. So we got 72 and EAX. I know it says RAX, but anything that has AX in it, or I guess AL, it's going to be the same register. And anything with DX is going to be the same as EDX. So they're just like different sizes. But we'll talk about that later. We're talking about sizes of registers later. But so what's inside of these registers? So RAX has 7.2 and RDX has 6A. So I want to see which one of those is the one that I input. It should be like a J. So let's look in Python. So a cool thing you can do is you can convert stuff to hex in Python. Yeah, it's a crazy idea. So let's see. I typed in Jack is dumb, so the first one should be, I think it's actually going to be Ford. So that's 6A. So that was the one that's in RDX. So that means it's comparing it to 72. So that's what we're looking for is 7.2. Now let's see what 7.2 is as a character. So we can take 0x72, and then we can just get the character that goes along with that. And that's an R. So the first thing is supposed to be an R. So we entered in a 6A, but it's actually supposed to be an R. And then we could just keep running through the program and just doing the same thing, just like, oh, the next one's supposed to be a 33. So a 3. And then just continue again, and it keeps breaking at our breakpoint at this comparison, and we're just looking at what is in the register that it's comparing to. So then it's a 7.6. And then we can just do continue again. And then we have a 6.5. Then after that, we have 72. And so you can kind of see like words or kind of like a human readable string is popping up there. So it means we're on the right track. So 5. Continue. Cool. What does that kind of look like?
Does it reverse?
Yeah, just like in lead speak, right?
Oh my gosh.
That's crazy. Underscore. That's 6.5. 6E. I'm just grabbing them each time from here because that's what it's comparing my input to. Got 33. Another one. And then a 72. And pretty sure if I run it one more time, then it says I lose, but now we could go ahead and try and win. So this time we'll enter in what we got. So looks like we got reverse underscore engineer. So we do reverse underscore engineer. Then we have the right password. Yeah, super sick, huh? So just by dynamically looking at it in GDB and like looking at the comparison that it was doing with our input, we're just able to figure it out without having really to do like anything too complicated or even like figure out what it's doing like in the program. We can just kind of find that comparison and then we're able to solve it. Cool. So now I think we'll jump into Ghidra and we're going to look at how this could have been even easier. So if you have Ghidra on your machine, go ahead and boot it up. And if you have any questions about starting Ghidra, Jack's the man for that. Hmm?
You like batch import stuff when you open
I just like import.
Okay. The screener like I would know. Batch import. I was like, I don't see why I would do that. Maybe that's for multiple files.
Yeah, that's what I think so. And then once you have Ghidra open, you can go to File, Import File. And from there, just find where your file is in your directories and then load it up by importing it. No. So you have to, if you don't have it yet, you have to go to the, I included as a link to the GitHub repo, and then you clone it, and then you can run it. Also, if it's giving a Java error, you have to have the JDK, like the 11 on there.
Go to the directory that's it, and then do You got it? We're doing Ghidra now, which is like a super powerful tool.
Yeah, Ghidra was made by the NSA to do binary analysis and exploitation. Yeah.
Yeah, but like we're doing an intro to like the tools. So I really don't do you have your
Oh, I'm gonna need your help in a second. Hey, when I get there, I'll ask for your help. All right. Ghidra.
Do you have working machine? Yes, but it's the one I set up for like I said to report, so I don't use them. Okay, so we should do is tell it off for some point. But for now, can you open up? If you go back to Ghidra, can you open the files? Do you have any projects? Yeah, actually, now do it's like how do you
Yes.
Or an additional read and just more.
Yeah.
I think you'd be better here because she makes focus on today.
Yeah.
And it's just secure that side. It becomes a lot more fun. I usually it's really worth it in my life. If you just make out for everybody and then kind of you have the file. Yeah, just on things like I think that you put that in there. Yeah, I think if I did, you might have to get an account. I don't know. I would look up, can't read language spec, Hydra, see what it says, the Windows version. Just look that up real quick and see how it says.
Now, setting up a Kali VM doesn't take super long too. Like if you're on this network, then you can just like download the ISO for it and then just boot it up, and it doesn't take very long.
Jack. Is that about Hydra or is that some other program? Yeah. I didn't know what it was. Oh yeah, put it. John,
So,
you're in.
to what?
Now where?
What?
FinX to NCX.
Oh.
Do I want, raw binary or?
Yeah, you left.
Yeah.
Is he running? Are you running Ghidra like in Windows?
Get the Kali box. That's a little too much. Yeah, he's running Ghidra on Windows. Do you have VM anywhere? If you have to do this is where go back to the home page of the training draw.
Just like.
It is important to do.
In there. And you do that.
Getting started.
Right, here you go. Okay. And then put zero. GHIDI.
Are we doing reverse too? Get that.
Yeah, we're doing reverse too.
Okay, then resolve.
Yeah, and I'll give a little bit more time here to get it set up, but I'll move ahead because we can just all see it on the screen anyway. So even if you can't get Ghidra pulled up on your own, then. Oh yeah, don't be on CNN or else they're gonna be These Comcast war rooms, or just war room, like that one, or this one. I actually don't do the Comcast one. This is the war show.
No, that's all good. Don't worry about it. Do you on the water Wi-Fi?
Put them there. So once you're on the war room Wi-Fi, you can look up like I really did it like last week. Like you can just look up the Kali VM, and then you can download it and get set up in VMware. You don't have VMware though. Then yeah, so it might take you a second, but I think we'll still move on. You can just see it on the screen, so. And Donald, you're doing all right?
Yeah, I'm ready to go.
Sweet.
Whoa. Oh, let's get home. Bring it all in.
Oh,
Because it never actually used
really?
Yeah, because it's all blocked out.
Wow. I'm gonna need you in a second.
Did you ever run into the problem where like your palm tools, like, just when you type in PWN, like just it isn't working? But like when I use my when I use GDP, like I can run it with on the bug.
Phone tools? Phone?
Like when I type in PWN, it's red and it like doesn't accept at all.
Can you bring it over here so I know you're talking about?
Yeah.
Yeah. We have
Oh, what's Pwn?
It just doesn't know what it does.
that now.
What is it?
It should just be like an airline code. But I,
Really?
if you don't know that, then I'll bug you know.
Isn't Pwn a library though for Python?
Yeah, there's also a tool for that's how like Awesome and Travis do it. But you can type like home and just like get stuff for a punch and like it runs like when you're gonna file something and then
I don't know. I've never even tried doing it from command line.
pick it up.
Are y'all still working on getting it installed over there?
Yeah, you can start.
All right, cool. Then we'll go ahead and get started on looking at this in Ghidra. So once you've done like the file, import file, and you've clicked on it and imported it and said okay, then it'll be here like in your current project. So you can go ahead and double click on it, and then it'll kind of do some loading stuff here. Now, here's a really important step. When it asks you if you want to analyze it, you say yes. Don't say no.
Never say no.
Don't ever say no. And then when it asks you again, just click analyze again. There's some extra stuff here, but usually you don't need to do that. I've never needed to do that. And then once you've done that, it'll load for a second, and then you'll be greeted with this. So this is a ton of information here on Ghidra, and hopefully it's big enough for y'all to see. I don't really know how to make it any bigger. But first thing I would usually do when I boot into Ghidra is I go to this window tab, and this is like all your different kind of tools that you have. And I like to have this functions one. I like to have this window. And this will show you all your functions that are in your current binary. And so then I'll go through and usually I'll just find main. I'll click on it. So we have multiple things going on here. We have a disassembly of just the assembly that's in the binary. And so it just shows you all of it here. So this is just like the same thing as if you use like obj jump. And so that's just the assembly in the binary. And then probably the coolest tool that's in Ghidra is the Decompiler, which takes the binary and turns it back into C code. And it's not perfect. Like, it doesn't really maintain variable names. So all of these are kind of, it's not super easy to read, but it's easier to read than it is to read assembly. So you can see in here, there's some variables defined at the top, and then it's reading in all of these hex like values into this array, which we can see up here was defined as local 58, and it's an array of 18 things. And then we see a printf, we see scanf, then we set a local here, and we do this for loop, and you can see even what's happening in here. Like it's saying like if your local thing at this index does not equal the local thing XORed with 0x17, then it's setting this to 0. And then it's checking this local at the end to see like whether or not you win or lose. So this is like a way easier way to see what is going on in the binary so that we could reverse it. So we could have just looked at this decompilation in Ghidra and said, oh, like it's putting all these things at a local 58 at these indices, and then it is using this for loop right here to go through those indices and just compare the user's input to what is in here XOR with 0x17, which is 23. So yeah, we could have just done that and then XORed each of these with 23 and then found the answer. So that's kind of an intro to Ghidra. Ghidra is a super powerful tool that like you'll pretty much use every single time you do reversing or binary exploitation, because yeah, you can look at things in objdump, but having the power to like load it up in here, analyze it, get all these function tags, and then also being able to decompile the assembly, so not only disassemble but decompile, is super powerful. And like even though it's not perfect, it is nearly there. What's up?
Is there an instance where like you decompile it and it's just absolute garbage?
Yeah, so there's definitely like anti like binary exploitation, anti-reversing techniques where even if like you can see the code, it is like super like obfuscated and hard to read. Also, like stripping labels from a binary like makes it where all of a sudden like this functions tab no longer works, and then you kind of are guessing what is like the main function. So yeah, even if this looks pretty easy in Ghidra, like there are cases where you have to do a little bit more work to figure out what's going on. Usually you can figure out like there's special tricks to find the main function based on like there's always going to be like this libc start main. So then this calls usually the main, or it'll set it up, and there's ways to see like the entry functions too. So just depends on what the binary is. All right, so we're going to continue using Ghidra in a little bit, but I wanted to cover something else before we get to that point. So I'm going to close this down for now. But in the Google Drive, I put a file called reverse3, and I want to go ahead and just go through that with y'all really quick. So just get it downloaded really quick.
So I have it on my system, and when I solve this, it just solves that.
It was a routine.
This is a specific one that we use.
Yeah, this is just
This part.
All right. Does everybody have the binary downloaded? Sweet. So I compiled this with a tag G option. So if we're in GDB, then I'll show you really quick. So if I set a breakpoint at main and run it, then let's see. Or am I in Jeff here? Oh, I am. Okay, well, I still have a solution to that. Oh, I need to share something with y'all really quick, actually. Yeah. I'm also going to go ahead and share the source code for this one with y'all really quick so you can see that.
What's a CICD? Pipeline, right?
All right, so there should also be reverse3.c in there now. And go ahead and download that too. So now, if I get out of here and run it again, instead of breakpoint at main and run it, then you can see, so we have two different windows here, and this will be the same between Pwnabug and Jeff. But so this down here is the C code, and it's pointing at like where we are on the C code. And then up here is the disassembly showing the assembly instructions and then pointing at which assembly instruction we're at. So if you have the source code and the binary in the same directory and you compile your binary using the tag G option for GCC, then you can kind of in GDB see both source code and the disassembly at the same time. So neat little trick there. But more using that so that we can kind of see what's going on here. So if we quickly just I'll look at the source code here, and that is this right here. Basically just have a bunch of different types, setting them equal to values using pointers and then dereferencing pointers. So let's go over just kind of what's going on in here really quick. So 3 different blocks and then this kind of last extra thing I tacked on. So this first block is setting 4 different variables of 4 different types equal to 4 different values. So we have a character, and I call it byte 1. That's equal to A, so that should just be a 1 byte type. And then we've got short, which is 2 bytes, and I set that equal to 10. And int, which is 4 bytes, and I set it equal to 2048. And I have a long, and that'll be 8 bytes. And so that is equal to this massive number. The values don't super matter. I just did that so that we can see something when we're looking at the binary. But really what I want to focus on is like what do types and type conversions and pointers and dereferencing look like in a binary. So if you're unfamiliar with types in C and with pointers in C, the general idea is that with different types, you have like different numbers of bits that you can store stuff in, like different lengths of bits that can kind of control how much information you can store within that type. So for a character, that is just 1 byte, which is 8 bits. And so you get the maximum value you can store is from, I think it's like 127 if it's signed, but isn't that it's 256 total if it's just a character, like if it's unsigned. What's that?
What about 8 bits?
Yeah, 8 bits. Is that 256 is the maximum number?
Yeah.
Okay. Oh yeah. I don't have the other ones memorized. But like as you move up, like because you have more bits, you can store larger things. And so with a character, you have 1 byte, which is 8 bits. But then with a short, you have 2 bytes, so 16 bits. And then you have 4 bytes here, so 32 bits. And then finally a long at 8 bytes is 64 bits, if I'm right, or is that 32 bits? It's a big one. That's why it's called a long. And I think there's even like a long type, which gives you even more. But so each of these is going to be represented differently too in disassembly. Like we don't store everything in the same types in disassembly either. So we'll go ahead and look at that after this. But I want to keep talking about the C code really quick. So we have our different types here. I think those are now explained. And then we have the syntax here with the star afterwards is C syntax for what's called a pointer. And so a pointer in C is, you can think of it as kind of like it's pointing towards, I know it's like that's using the word that is called it to like define it, but it is pointing to something in memory. So it's a memory address of something that then is storing a value. So rather than just being the value of something, it is pointing towards that thing, towards the value, and it's the memory address of that value. And so usually you'll see that like represented as just like a box and arrow diagram. So like a pointer, instead of just being like a box with like 10 in it, it's a box that has an arrow that points towards a box that has a 10 in it. And so also what I'm doing here is this and is like is the syntax to get the address of a type. So pretty much I'm just making these pointers to like point to where these guys up here are. And so I just want to look at like what that looks like in assembly too. And then finally down here, I'm kind of replicating what I did up at the top block, but I am using this star, which right here is a pointer, but down here is used to dereference a pointer. So that is something that's always been confusing to me in C, is why they use the same thing to make pointers and also dereference pointers. But if you dereference a pointer, then you go towards the thing that the pointer is pointing to and you grab it. So if we make this character byte 1 and we then make a pointer to it and then we dereference that pointer, we're pretty much just getting the same value between byte 1 and byte 2. And so that's happening for all of these types here. So pretty much all the byte 1, byte 2, short 1, short 2, int 1, int 2, long 1, long 2 should all have the same values stored in them. And then these pointers are just pointing towards those values and where they are. And then this syntax down here, this char star string 1 is just defining a string. So I just made it a 2-letter long string. And then I'm doing a type casting down here at the bottom. So I made a short and I'm casting the string and I'm dereferencing it, and then I'm casting it into a short and storing it in here. So kind of want to look at like what does that all look like in GDB. So go ahead and get out of here, and we'll look at it in GDB. So set a breakpoint at main, and then let's go ahead and run it. So we're on this first line, and we have the character, and then byte 1 equals A. So what we'll see here is that it's taking this value 41, 0x41, which corresponds to ASCII for A, and it's putting it on the stack at RBP minus 0x3b, and then it says byte pointer. So what this means is that we have these 4 different things. So we're going to talk about that really quick. So when you're moving stuff around in assembly, you have 4 different sizes for types that are defined, and they kind of correspond to like the C types. And so these 4 instructions right here directly correspond to these 4 lines of code right here. And so you can see this byte pointer is being used for this character. This word pointer is being used for the short. The double word pointer is being used for the int. And then the quad word pointer is being used for the long. And so that kind of gives us a clue as to like what is happening here, because we remember like a character is 1 byte, a short is 2 bytes, an int is 4 bytes, and a long is 8 bytes. And so it's the same correspondence here. So when you're working in assembly and you're moving amounts of stuff like between different locations, you have to say how much stuff you're moving. And so when we're moving something that is 1 byte, we say byte. Then if we're moving something that is 2 bytes, in assembly, 2 bytes corresponds to a word, or that's, I guess, 16 bits. And then a double word corresponds to 4 bytes. And then a quad word responds to 8 bytes. So that's what that looks like in assembly. So if you're seeing this kind of these different types here, they're corresponding to different amounts of bits that you are moving between different places. All right, so any questions on the different sizes there and how they correspond to C types? Cool. So I'm going to go ahead and just like move past this block. We're going to move past and onto this pointer block. So we kind of see, I'm going to move one more down here. We have another 4 instructions that, or 4 lines of C code down here. And it looks like it kind of corresponds to 4 load effective addresses and moves instructions. So I'll go ahead and run this one more time. There they are. 2 of them are grayed out up there because we moved past them. But so what we can see is when you're creating a pointer to something, you use this load effective address assembly instruction. And so what does that really do? It grabs the address of something that is like on the stack, and then it puts it in a register, and then it takes that address and stores it on the stack. So exactly what we're talking about, like with a pointer, it's really getting the address of something, like where it is, and then saving that. So that's what it looks like in assembly. Is if you see this sort of like getting the address of something and then saving that address somewhere, then that means you're starting to deal with pointers. And then, so also I want to see, I'm going to run this one more time so we can see these up here. These are the addresses of each of these variables like on the stack, and they just directly correspond down here to the load effective addresses. So like our first character right here, this byte 1 is at RBP minus 0x3b. That's also like when we could do this load effective address, it's just getting the address of this byte, this byte 1, and then putting it into our RAX register. And then we take what's in the RAX register and put it on the stack at 0x8. So we're just taking the address and then moving it into our pointer variable, or this like byte 1 pointer. So any question about pointers or just like what that looks like in assembly? And if it doesn't like super make sense now, that's okay, because if you haven't dealt with pointers before, they're like probably one of like the most tricky things. Even if you've been working with them forever, like they're always kind of annoying to deal with, but super integral to programming at the end of the day. And then I want to look at this last block, so past the pointers and at the dereferencing, and kind of look at what that looks like. So now we're down here at the dereferencing and then storing in here. So let's see if we can find a repeated pattern in this code. We'll move down here a little bit. All right. So it looks like move down a little bit more there. So we kind of have this repeated, though it's not repeated for every single one of them. But what we do is usually you'll see something being moved into RAX, and then you'll like the way it's going to be a dereference is because it is directly there's no offset that corresponds to the bracketed like expression here. Normally you'll see like RIP plus some offset or RBP plus some offset. But if you ever see like RAX in brackets by itself, that means that up here, like we moved the address off the stack and we put it into RAX, and then we go to that address that was in RAX and we get the thing that was there, which was a quad word, and we move it into RAX. So that's what dereferencing sort of looks like, is like grabbing that address that was stored on the stack and then going to that address and grabbing the value that is stored. So pointers are a little bit kind of hectic to think about there, but we're more just going for a like recognition of what that looks like in assembly. Cool. So we got that down, and then I want to look at one more thing, which is the block down here at the bottom. Oh. Oh, Raggy. Oh, I think it didn't do anything with my my last values there.
Did not even do the string to the compiler.
Yeah, so looks like we got a compiler not compiling everything that I wrote. So if we look inside of
Sometimes if you make a variable or a string and you never use it, like you never print it out or anything, the compiler will just be like, you don't need that. And it won't actually like put it into the assembly code. It makes sense. If you don't use it, you don't use it. So all John did was say that string 1 equals but he never like did anything with string 1. So
yeah, and I thought maybe I could get away with it, but wasn't meant to be. Now I'm going to use it though.
that's not important though.
Yeah.
That's just a little quirk about compilers.
And then this is what I was talking about earlier. If you want to, you want to have the code pulled up alongside the disassembly in the GDB, you use this tag B option when you're compiling. So now if we go back into here and we set our breakpoint at main, run it. I'll try and get down to the bottom here. Now let's see if it actually does stuff this time. Looks like we are doing stuff this time. So what's happening here, it's loading the address of AH, which is our string, into RAX, and then it's moving that address of that string into our quad word pointer. So that gives us a hint as to how big that address is. Also, addresses are going to be 64 bits. So that's why they're using quad words as well, because we're in a 64-bit system. 64-bit system means all addresses are 64 bits. So if we're moving 64 bits for an address, then we need to use a quad word pointer. So then after this, we're saving that value onto the stack, and then we're moving it back into RAX, doing some stuff with it. But really what I wanted to see here is like what happens when we do a type casting. So if we move down to this line, so we're grabbing the address of the string on the stack, and then when we convert it over to a short, it looks like it's taking it as a byte pointer instead. So it's moving it from a quad word pointer to a byte pointer and moving it into EAX instead of RAX. And so if you see something like this where you're like moving stuff around from a bigger size to a smaller size or vice versa, that usually means that you're doing some sort of casting between types. So something to look out for when you're doing reversing. So all this stuff right here is corresponding to that. So it's moving, I think, 1 byte at a time, because maybe for some reason that's just the way the compiler wants to do it, but it should be moving 2 of them because it's a short. Cool. And then it's setting up our call for printf here. We're going to call it. And did it print anything out up here? 65. Cool. And then we'll go ahead and exit out of here. All right, so kind of useful if you ever are doing a reversing problem and you kind of run across that stuff. At the end of the day, the biggest way to like figure out what is going on in one of these reversing problems, if you start seeing crazy stuff like that, is start like making your own C code and compiling it, and then like seeing how that corresponds to what like the patterns you see in the disassembly. So now to finish off this lesson, I want to give y'all a challenge. So in the introductory drive, I dropped this basic analysis binary, and I'd recommend going ahead and opening it up in Ghidra and trying to figure out how to reverse it and then win the binary. So we'll also end off the lesson there too. I got nothing else.
Go to the drive where yeah, you would run. Yeah.
You still working on Oh, cool.
I just need to go same website.
The basic analysis.
Yeah, and so I'll let y'all loose on that challenge for now, and then tomorrow we will get it together. But just a little challenge to.
You're talking about the basic analysis?
Mhm.
Okay.
It's the one that Wiki was really full. Why wouldn't you just teach us phone tools from the start? Why would you just everything just in your name?
Right.
Yeah, by the way, the university has stuff that existence, so.
I'm just gonna start off by just one thing.
Sure, Sure, actually, I gotta go.
This
I gotta
also
go.
these names.
Right, I gotta go.
Okay.
I got a boarding pass, I got a board. You get the, you get the. Okay, so now if you get a file.
Yeah.
No, not this one.
Reorganizing the drive. It's a lot easier to.
It's doesn't be very good.
That's where easier. So really all you have to do here is you go click on the node and then just click on the copy. Then you'll go to your terminal. Oh, you can do Control Alt T or just click on it there. And then
Just checks out.
you can just do it here. So you get the orders are identical. It'll be 2 words.
So now file.
And then you'll paste.
File.
Jack, Mary's. Just as a double check on pages. Can you hold up number 3?
Yes.
What do you want?
Trade. So that's taken this
Trade?
in like repo.
Don't look at the screen.
Oh,
Don't
okay,
look at
okay,
the screen.
okay, I'm not looking
He's
at
good.
that.
He's good.
Trade.
Yeah.
So it's just gonna be putting it in your home directory. So like after it's done, we just LS file it there.
You understand.
I've never done live fire.
Let's make it easy. Crypto.
I've done
or
crypto.
Crypto or general CTF.
So then LS.
When I download it, I'll do your VM.
And then
Because I like.
Live fire is happy with just CTF.
oh wait, I'm sorry. I'm doing
The other half you're like doing a lot.
You can go ahead and do R and space. Sorry, we had a John.
Okay.
Sorry, there's a college questions.
It's a Christian.
We know you put software devs.
Yeah. Then maybe further, there it is.
I don't know. Wi-Fi sounds really interesting just because it's like this is actually massive. Are you okay? Yeah, I do like software dev.
Yeah,
just
so
'cause-
downloading either release files or click on the blue.
Are you doing what I
Zip
do?
files.
Just like as a person, like I feel that they all see, and you're copying my process.
Yeah, after always forget, like, click on the repo.
You're doing what I
Drive,
think you're
yeah,
doing.
zip files, and they always have like install
Just went to watch the weather.
Okay, okay. What does it stand for? Like, you know what you did?
The top one.
Don't even think about it.
I'm not. I'm like, you're not.
So then you go back to your terminal.
Obviously, don't do that.
So I would move the zip file from your downloads. Oh, now you're just do CD with your
On a grade, how do you feel about her waves kind of CI/CD pipelines? Oh, that's a yes. That's a yes. That's a yes.
You would love that.
Integrates is like
I promise I'll be good at integrates.
Just like DH and then tab, and it'll autocomplete it for you. There you go. And then do dot. Dot is your current directory. So removing it from downloads to the current directory. LS.
Yeah, go ahead.
Now you can see it there. So zip files will run on zip.
Don't we all?
I mean, there's a lot of stuff there.
Really sink in.
Yeah, I'll see.
Literally, he said he was in CST.
Yeah, let's do it. Let him show it.
I mean, if
You're
he's
gonna chase me on this team.
Report. Fine.
So now you have it.
What's that? So sudo one.
I was thinking about
Yeah.
that.
You have to sort your background.
Oh, it's
Every time I get
No, just tell me.
oh, never mind.
I got it.
space APT.
Wow, it could not have been more than
Stupid.
that. Yeah.
So we need to do
Your
open,
Yeah, there you go.
11. Oh, sorry. So this time
Did
there's
you know
space.
where
that
it
is-
is? Because I know
It's what?
And then it's actually
Okay, guys.
Sorry. I was on the verge of everything making sense,
Put it all.
and then I just completely lost it. I'll probably never be able to.
Oh.
Wouldn't do it. You're like, why would you
I just clicked. I was like, click to I'm
Are you interested in crypto capable? I would recommend. Are you live fire or are you like dead fire?
Not that. That's why I put policy, because I'm like right there.
The meat grinder.
So they'll just get downloaded there, and also you can really just use it on the network because they recognize it as a valid EM and you just don't have access. You can't.
So I think I just.
Hey, okay, wait.
Like, we're all gonna be even about
Hey, if you're a
it.
cyber major, I need you to raise your hand right now.
Do I have
Good,
to?
this is good.
We got one, we got two, we got three.
If you're a
Okay.
plebe that wants to be a cyber major, also raise your hand.
Yeah.
Woo! Alright, this is
Yeah.
good. This
Okay,
is
if
good.
you're a plebe who wants to be a cyber major but is going to change your mind to CS after winning this policy module, raise your hand.
I did
policy.
You serve as a cyber. Okay, please, I know you want to become cyber majors, but it's objectively a better major.
It's
Hear
objectively
me out.
better major.
No homework.
Actually, that's true.
That's a good idea. That's
That's
just
true.
say,
That's
just
true.
say.
bro, cyber is
So
so
true.
easy.
Like, you don't have to do any homework.
Cyber is so like this. This is harder than anything I do.
I literally-
But I want to do this all the time.
Hey, by
John.
April
It's a
They're man.
different one.
I mean,
Yeah.
you're working code. You're really working code standard, and then you're
Oh,
Does
I
it go
know,
bad?
like a cat
I
line.
just-
Oh,
Yeah.
No,
you don't
the
like to
homework,
grind that out.
the homework we had to convert the Python to C.
Why don't we have
Okay, wait, what's that difference? Our homework
Put
was
inside your program.
like.
Every time we have photos.
No, we did that too. That was our homework too.
Oh, stupid.
It was literally, it gave you Python code, like literally like a full function, and you had to make the function C.
Hey,
So like just define the variable.
Yes.
What's the time?
This is
This back class is it's this engineering, it's actually some engineering. There's actual like things out there.
We need to figure it out.
I'm not saying it's other ones. I'm only
Honestly, so often.
Super.
That's who it is. Like, oh, that's a class and I'm gonna get a
No. Like, it's like.
Don't worry about it too much.
I got that.
Yeah, good. All right, thank you. That's all I need to do.
Second class. That's kind of how I was. Yeah.
Here.
Yeah.
Oh shit, he doesn't sign attendance.
Whoa.
I saw that there's a playground who got like mid of the month or something, and I looked at their the write up for it. It's like ECA's cybersecurity team. I was like,
You know it's crazy though?
interesting.
You know what's
Do you know something?
Was like, I don't know.
I mean, why would you lie about it?
Mid of the month for games.
God, we're so freaking
She's
cool.
such a great.
Yeah, I'm
Actually,
Oh,
she's a
yeah,
great
working
boss.
here, you can see that this first bit.
But like, that's
You know what's crazy, bro?
Because I know a person that does.
If I make a program and I say,
Okay, but
"It's
So funny.
somebody that makes
Okay, that's kind of scary.
We talk about it. The teacher doesn't know that there's.
Oh, no.
The teacher doesn't
I can't do
know
anything.
Search.
What did you? Is it like the
What did you
hockey, like?
Oh,
yeah.
Were you trying to set up an alias and you just deleted everything? No.
She's so strange.
I just very bad. Like the officers that show up and they're just looking
So, like, we're looking for animals like that.
You remember on MLS?
My brother.
You remember
Yeah, she's just. No, that's my dad. My dad.
Okay, that's a start.
And you can see the main function. You can look at that like remember when I pulled up the stuff, you can see a map in that case. In which case you go with that.
It is weird. Like, people
Yeah.
have that version right now.
I can't look at it.
Laying down.
Yeah. What do you think?
Every couple months I'll
Yeah, what if I go like?
There you go.
These guys are.
A lot.
So now that you have it, you can LS every direction as long as you're in this direction.
It's like a land.
Stop.
Integrate.
You just need to fix your dot. No, don't do it again. Just maybe bin it first and see what's in it.
Wait, why would he been it?
Uh-oh. Jack, sorry.
I need to go in
It's broken, so.
Lance, I can only use.
How do you do this?
Why are you trying to go to this?
broke them, now he can't re-edit it.
No, I think he can't use anything.
What happened to him?
He can't even access it anymore because he fucked up his password so bad that now none of the variables in Gen are not accessible, so you can't access any programs.
Oh, I see.
He can't even CD.
I can see you can echo. Like a dot slash LS.
So like.
Dad's disappointed.
I know
Christian, just look up the default path. They just give it to Lance and then just put it in his
No,
brain.
he literally overwrote the entirety of the like.
Right, we can just, can't you look up on Google and say for
So it's
example,
I'm just gonna delete. I'm just
3.5
gonna
to
change
4 hour like
how it's doing it on the
competition
tab.
modules. So like crypto would be like
You forgot to do the
6
polls.
challenges
Yeah.
and like 1 or
Lance,
3.
you are killing me.
It'll be like a couple easy, couple medium.
That's such a easy like.
Yeah, you work with a 4-person team.
What do you mean? You can add your entire
They were like,
And then,
alright,
the scoring
and
is-
then it overwrote my entire path.
It's weird.
They didn't say, hey, make sure
No, they
you
didn't.
literal
Basically,
most
like, we have
important
enough
part.
that we're gonna
This is an Arch Linux too.
absolute Slayers, Slayer teams, and then like development team. Yeah, we're like good teams, but-
Alley Arch Linux.
Why
No.
are you doing it? Oh my god. I couldn't find another video.
Yeah, so.
Don't look at videos, just read text, like you have eyes.
Yeah.
They can read, right? Like you're not fucking illiterate, are you?
This was a bit of a tricky one.
Literally the
We have information, I have like pulled it up, so like. Originally.
And I made it so that the local bit is in your path.
Now do code.
Hey, John.
It's still not.
There is a way.
Literally developing. There's a string called win, yeah.
Usually we haven't done it internally before, usually we outsource it to cyber department. So we code it ourselves and then like.
They didn't even take the bag from me. It was like I held the bag out in front of them, and they like put their hands out, and I dropped the bag.
Oh,
and
and
like
that
let them
they
get
uncheck
it.
requires.
So basically, like they told us to like fuck off, and then I
You know
said,
why?
okay, cool, and fuck you. And then, did you see my emails? He's like, I don't know what to do with this class.
I think it does, but sometimes it might not have a null right, but if it's looking for null terminated strings, that's because like C strings are normally terminated. Normally, but maybe they're not.
Everything's about
some
So yeah, super awesome thing in
Yeah, like touch
in
me.
features, if you double click on like taking next to it, figure it out.
Yeah, pause.
I'm gonna.
Maybe it was good times.
So now we're here.
I don't like. Whoa! I don't like this angle. I don't like this angle. Get back over here. Stop getting jealous.
Actually, the entire software dev A team is Christian Rose.
Yo! Please don't. You mean my cap stuff?